Continuing with our study guide, we are now on problem number 32. Sine u is -5/7. It's in the third quadrant. We need to find a sine of double angle, cosine and tangent of double angle. Those are the formulas. Since sine -5/7 is in the third quadrant, we can sketch our triangle in the third quadrant. And then our cosine, in order to figure out the other leg, we're going to take our square root of 49 minus 25, which is square root of 24, and you can simplify it into 24 is, what is it? It's 4 times 6, so it's 2 times square root of 6, 2 root 6, and it has to be negative because it's in the third quadrant. So then cosine u is going to be -2 root 6/7, and then tangent u is going to be sine over cosine, so -5 over -2 root 6, 5 over 2 root 6, or we can say 5 root 6 over 2 times 6, which is 12. They're positive. And then you just plug it into those formulas, so here's what you're going to get. For sine 2u, you're going to get 2 times the sine, which is -5/7, times cosine of u. You simplify it to this value. For cosine of 2u, I used this formula. You can use either one of those. There are 3 total. So it's going to be 1 minus 5/7 squared. That is going to be, oh, should have been 2. So should have multiplied it by 2. Times 25, so that is going to change my answer a little bit, because now I am subtracting 49 minus 50, so that's -1/49. For tangent of 2u, it's 2 tangent u, so 2 times 5 root 6/12. I can simplify it a little bit, and then 1 minus 25 over times 6/144, so also simplifying. 144, it's 12 times 12, so that's going to be 24, I believe. And now we have 5 root 6/6 divided by 24 minus 25, that's -1 over 24. Since we're dividing, we have to multiply by the reciprocal, so 6 goes into 24 4 times, so we're going to end up with -20 times square root of 6. Those are our 3 answers. All right, moving on. For half angle formulas, those are our formulas for sine and cosine. For tangent, I will just divide sine u over 2 over cosine over u over 2. Now, for those formulas, we have plus minus. We have to decide which sign to use. U is in the third quadrant between pi over 2 and pi. So that means that u over 2, if you divide both sides of this inequality by 2, you're going to get that u over 2 is between pi over 4 and pi over 2. It's in the first quadrant. So actually, both of those are positive, and we don't need to worry about the plus minus sign, which is going to have a positive value. However, in both of those formulas, we need to have, it should have been 1 plus cosine u. We should have had cosine u, and we only have sine u. So we are using the same technique that we used over here to figure out cosine u. So we are in the second quadrant. Sine is 5/13, so this is 5, this is 13. This is our classical Pythagorean triple, 5, 12, 13. So this side is 12, -12. So cosine u has to be equal -12/13. And we just plug it into the formula. So let's try to do that. Sine u over 2 is going to be equal 1 minus -12/13. So that's going to be plus 12/13 all over 2. Simplify this a little bit. 1 is 13/13 plus 12. So that's 25/13 over 2. That's over 26, which we can simplify to 5 over square root of 26. And once we rationalize the denominator, 5 root 26 over 26. For cosine of u over 2, we're going to have a similar thing, but we will have a negative because it's 1 plus cosine u, so it has to be 1 now minus 12/13. And that is going to be 1 minus 12, that's 1/13 over 2, that's 1 over 26. So we end up with square root of 26 over 26. And then for the tangent, we just divide sine over cosine of u over 2. Since the denominators will be the same, it's just 5 root 26 divided by root 26, which is going to give us just 5. Tangent u over 2 equals 5, right? 5 root 26 over root 26, those will cancel. Solving equations. Sine x equals sine of 2x. On the right side, we know it's 2 sine x cosine x. I'm going to subtract sine x from both sides. So I have 2 sine x cosine x minus sine x equals 0. And then I'm going to factor out sine x. So I have sine x 2 cosine x minus 1 equals 0, which means that either sine x equals 0, that's why I did not divide both sides by sine x, so sine x can be equal 0. I'm going to write it here, sine x equals 0, or cosine x has to be equal 1/2. If sine x equals 0, that would mean that x will be equal on the interval between 0 and 2 pi, x is going to be equal 0 and pi. Cosine x equals 1/2. That means that x equals pi over 3, and not 2 pi over 3, 2, 3, 4, 5 pi over 3. 5 pi over 3 on this interval. Our next one, we're solving it in degrees. We have cosine theta minus 1 equals cosine of 2 theta. I'm going to write cosine 2 theta as 2 cosine squared theta minus 1. And that has to be equal cosine theta minus 1. If I add 1 to both sides, they cancel out. And then I'm using the same idea that I used here. I'm going to factor out cosine theta. I'm subtracting cosine theta from both sides and factoring it out. So I have 2 cosine theta minus 1 equals 0, which tells me that either cosine theta equals 0 or cosine theta equals 1/2. But now we are in degrees, so it's not going to be pi over 3 and 5 pi over 3. That's going to be 60 degrees and 300 degrees. And cosine theta equals 0. That means that theta would have to be equal 90 degrees and 270 degrees. Those are our options. Tangent x minus cotangent x equals 0. That means that I'm thinking it's going to be pi over 4. That's when they're equal. But let's do this properly. So tangent x is sine x over cosine x minus cosine x over sine x, and that has to be equal 0. I'm going to bring those two fractions to the same denominator, so I will have sine squared x minus cosine squared x over sine x cosine x equals 0. That means that sine squared minus cosine squared has to be equal 0. In other words, that means that cosine of 2x has to be equal 0, which means that 2x has to be equal pi over 2 and 3 pi over 2, which means that x will have to be equal pi over 4 and 3 pi over 4. When x equals pi over 4, both tangent and cotangent equal 1. And then when x equals 3 pi over 4, both of them equal -1. For number 37, we have something similar. So I'm going to write down cotangent as cosine over sine. And then cosecant, it's 1 over sine theta. And that has to be, and that has to be equal 3. So that is 3 sine theta over sine theta. So same thing, common denominator, which now I can drop. So I will have cosine theta plus 2. Oh, how interesting. Cosine theta plus 2 equals 3 sine theta. And let's see. Once we have cosine theta plus 2 equals 3 sine theta, what I did here is I used Pythagorean identity. Instead of sine theta, I wrote down it's 1 minus cosine squared theta. And then I would square both sides of this equation. So I have cosine squared plus 2 times cosine, so that's 4 cosine theta, plus 2 squared, which is 4, equals 3 squared, that's 9, and then multiply by 1 minus cosine squared. Then I am bringing 9 cosine squared theta to the left side, so total I have 10. I have 4 cosine theta, and then I will have to subtract 9 so that I have minus 5. I'm using quadratic equation to solve this, and once I get a cosine theta equals this value, I would have to use a calculator. So using a calculator, I would get that theta is 57.6 degrees, or theta equals 159.2 degrees. But this one is solved with the calculator. Okay, because we have this weird value we don't have, it's not one of the special angles. All right, that's gonna be that for part number 4, and then in next part, in final part, we're going to solve, oh no, one more thing, I did not finish 31 in previous part, so over here I just plugged in the values. You are welcome to pause and look at this. Last time we already calculated sine v and cosine u, so all I did is I just plugged them in. So 31 is here, and then next time we will finish those pieces.